Okay, here comes some midterm review. The first section is going to be about data. The four different types of data are nominal, ordinal, interval, and ratio. And this is important because there are certain things we can calculate from data types, certain colors that we can use to symbolize different data types, and it's important to know what those rules are. So nominal data, things like you, me, them, Minnesota, Texas, Finland, blue, spider, fettuccine. These are categories, names. There's no rank to them whatsoever. With ordinal data, it can be large, medium, small, or how do you feel today? Very unhappy, happy, okay, happy, very happy. So there is an implied rank, but these aren't things that we can necessarily measure or stick actual values on. Interval data. So both interval and ratio are numbers, but the big difference is, well, we'll get there. Numbers, interval numbers are on a calibrated linear scale, but they lack an absolute zero value. For example, 0 degrees Celsius doesn't mean there's no temperature, right? Values on the scale are equally spaced, 1 degree, 2 degree, 3 degree, it's the same distance between them, just like on a ruler. And interval values can be added and subtracted, but not multiplied or divided. So, example, 10 degrees Celsius plus 10 degrees Celsius is 20 degrees Celsius. But 20 degrees Celsius isn't twice as hot as 10 degrees. It's different. A pH of 2 isn't twice as acidic as a pH of 4. We can't make those kind of ratio comparisons with interval data. So think about that meaningful absolute zero value. With interval data, we can calculate a mean, a median, mode, standard deviation between a set of interval observations. For example, if you had a temperature, an average temperature in Fahrenheit for every month of the year, you could calculate a mean, median, mode from them. Ratio data is, the data mecca. These are numbers with a meaningful 0 point. So $0 actually means no money, and zero population means literally no people. We can calculate mean, median, mode, standard deviation between observations of ratio data, just like with interval, but we can also calculate ratios. We can multiply and divide ratio data. $40 is twice as much as $20, the same way that $20 plus $20 equals $40. So we can do all of the arithmetic on ratio data. That's really important to be able to differentiate those. Here's a quick chart. You can pause if you want and take a look at these, what we can do with the four different data types, and if you want to read a great 2-minute little summary, that's a really slick little link for you. Okay, taking it into Tableau, we work with dimensions and measures. Those are the variables we work with. And if you look over here, this should be very familiar to you when you load your data set. The top half, these are the dimensions, or not half, but the top section are the dimensions. These are the independent variables. They're usually discrete, nominal, ordinal data, categories, dates, instructor, subject, course, like you see here. The lower section are the measures. These are the dependent variables. They're always continuous values that can be aggregated. These are, our classic quantities. These are the basically the things you want to be analyzing about your data. And it's important to know that when you drag a measure into the view, Tableau's automatically going to apply an aggregation to whatever measure it is. Okay? There's a really important difference between these. Separate from dimensions and measures is the coloring, which tells us whether the data is discrete or continuous. So they're definitely related, but we can take data that's continuous and make it discrete, like we do with scatter plots. And so the blue versus green represents discrete versus continuous data. So the discrete is often related with our dimensions because that makes sense. And then the green fields are often associated with our measures because they tend to be continuous, but it doesn't have to be that way. Green measures are treated as an infinite range. And when you drag them into the view, it usually adds axes to the plot. But the dimensions, which are in blue, are discrete. These add headers, and I'll show you what I mean. So between these two plots, notice that quantity on the left is being treated as a continuous measure, and on the right, quantity is being treated as a discrete feature. That's why over here it's being treated or being drawn as a line because it's continuous. So it's saying between these, this is a continuous thing, a line plot is appropriate because this is being told it's continuous. Notice that you've got an axis down here that's labeled as quantity. When we make quantity a dimension or a discrete measure, notice that we've got a header label instead of basically an axis. So it's giving us the labels down here, but it's being treated like a header with spaces between the bars. So it's still on the y-axis showing us the sum of sales, but quantity is being treated as a continuous variable here or as a discrete variable here.